For this example, we have x plus 4 over x squared plus 12x plus 20 plus x plus 1 over x squared plus 8x minus 20. Alright, so when you have a situation like this, the first thing you need to do is factor those denominators. Right? We can't do anything until we figure out what we're actually working with here. So I'm just going to do some standard factoring. We want factors of 20 that add up to 12. What are two factors of 20, or two numbers that multiply together to get 20 that add together to get 12? How about 10 and 2? 10 and 2 do the trick, so that's our factorization there. In the second one here, we need two numbers that multiply together to get negative 20, but add together to get 8. How about, I'm thinking plus 10 and minus 2 there. 10 times minus 2 is indeed negative 20. 10 plus a minus 2 is indeed positive 8. Okay, so that gives us something to work with here. Now we're ready for our least common denominator. And the way you get that is just by listing the terms in the first denominator. So we have x plus 10, x plus 2. And then we go to our second denominator and ask, what do we need to add to our LCD to make sure we completely include the second denominator? Well, x plus 10 is already in there. Oh, but we need an x minus 2. So there's an x minus 2, and now that's included as well. So there is our LCD, x plus 10, x plus 2, x minus 2. Let's rewrite both of these expressions. We have x plus 4 over x plus 10, x plus 2, and then we have plus x plus 1 over x plus 10, x minus 2. Alright, now we need to fix up the denominators to make sure they're both equal to this LCD. X plus 10, x plus 2, x minus 2. What are we missing in the first one? We are missing x minus 2. So I'm adding that in, but we can't do anything on the bottom without also doing it to the top, so we do an x minus 2 on the top as well. There we go. How about our second term here? We have x plus 10, x minus 2. We are missing an x plus 2. Add that in on the bottom. And again, do the same thing to the top because really we're just multiplying by 1. There we go. Okay, so now we have all of this over a single denominator of x plus 10, x minus 2, x plus 2. And let's see here. So we're going to have to FOIL both of these together. So let's do that. So we have x plus 4 times x minus 2. Foiling those gives x squared minus 2x plus 4x is plus 2x. 4 times negative 2 is minus 8. Alright, for the second one we have x squared, so plus, that's this plus here. Now we have x squared, so x squared plus 2x plus 1x gives us plus 3x. And then 1 times 2 is 2, plus 2. Okay, so now we'll combine like terms. 2x squared, 2x plus 3x is plus 5x, minus 8 plus 2 is plus, make that minus 6, all over x plus 10, x minus 2, x plus 2. The next step is to attempt to factor that top trinomial to see if anything cancels. I've already done that on the side. It doesn't factor. This is as good as it gets. Thus, that's our final answer right there. Let's try another one. Here we have 8 over x squared plus 6x plus 5 minus 3x over x squared plus 4x minus 5 plus 2 over x squared minus 1. Step 1 is to factor all these denominators. So let's see what we have here. Alright, and with these, they're always of the form ax squared plus bx plus c, and we want factors of c that add up to b. That's kind of the way to remember it. Factors of c that add up to b. Okay, factors of 5 that add to 6. Alright, how about 5 and 1? X plus 1. Okay, factors of negative 5 that add up to 4. How about plus 5 and minus 1? And then this one here is the difference of squares. So that just factors as x plus 1, x minus 1. Okay, let's grab our LCD. LCD, we just start with the first denominator, x plus 5, x plus 1. What do we need to include to make sure we completely include the second denominator? We have the x plus 5. We don't have an x minus 1, so let's add that in. Move on to the third term. What do we need to add to make sure we completely include the third term? Well, we have our x plus 1 and we have our x minus 1, so we're good to go there. Thus, our LCD is all of this, x plus 5, x plus 1, x minus 1. Okay, so what are we missing here? We go term by term. This is going to get a little messy, but I say we just stick with it. We have x plus 1 and x minus 1, so in this far right term here, we're missing x plus 5. X plus 5. Okay, in this middle term we have x plus 5 and x minus 1, so we're missing x plus 1. X plus 1, and we add it to the top and the bottom. So I'm going to put it down here with our terms, x plus 1. Because we're just multiplying by 1, so we always do it in the numerator and the denominator. Okay, on this left term here, what are we missing? We have x plus 5 and x plus 1. We are missing x minus 1. I do it on the bottom. I do it on the top. X minus 1. Okay, this is getting a little messy. Let's clean it up. So I know we're going to have all of this over a single denominator of x plus 5, x plus 1, x minus 1. Let's see, so then up here we have 8 times x plus, make that x minus 1, minus 3x times x plus 1, plus 2 times x plus 5. Okay, so now we just clean up this numerator here. So let's distribute this 8 through, so we have 8x minus 8. Distributing the negative 3x gives minus 3x squared minus 3x. And distributing the 2 through gives plus 2x plus 10. All of this over that same denominator. Denominator is just going to hang out for a while here. Okay, let's combine our like terms. Well, 3x squared is kind of off by itself here, so that's okay. We have 8x minus 3x plus 2x, so that's plus 7x. And then we have negative 8 plus 10, that is plus 2. All of that over our denominator, x plus 5, x plus 1, x minus 1. Okay, I've already tried to factor this trinomial. It doesn't factor. But you'd want to at least try that to see if you can get any additional cancellation. In this one, I already know that you can't, so I'll save us some time and not mess with that. So there's our final answer.